Hello, everyone, and welcome to this video. In this video, we're going to talk about Unit 5, Handling Data for Probability. In this video, we're going to talk about theoretical probability. Theoretical probability means what? It means it's a theory. It's not an experiment. This means that all the events have the same probability. All the events have the same probability. For example, if you have a coin, and the coin has heads and tails, the probability of heads will be 1 over 2. Probability of tails will be 1 over 2. So all the events or all the outcomes will have the same probability. Same idea with die. If you have a die that has or six sides, so each one has the probability of 1 over 6. That's the idea of theoretical probability. And the probability or the theoretical probability is the number of successful outcomes over the total number of possible outcomes. Now, let's take a look at one of the examples here. One of the questions talking about theoretical probability, because it's understandable here. If we have, for example, a coin with heads on both sides is tossed, if event A is defined as the coin landing head side up, calculate probability of A and probability of A not happening. So the probability of A, if event A is defined as the coin landing head side up, so heads will be up. Calculate the probability of A. This means it might happen or it might not happen. So I don't think this one is important for you guys, because a probability of A is the head up side, or it means we get heads. It's 1 over 2. Why is it 2 over 2 here? Certainly probability of A not happening is 0. It will not happen. Maybe heads side down. The, a coin with heads on both sides is tossed. Oh, heads on both sides. Sorry, I didn't focus on this. Yeah, because I was guessing that there's tails on the other side, because both of them is are heads. Both of them are heads here. This means that heads both side up will be both of them. So it's going to be 2 over 2. Because for a second I thought the coin will be heads and tails, but here it said heads on both sides. So yeah, this means that it's 2 over 2, and the other one would this is 1. This means there's no other possible outcomes or no other possible probability, because the sum of all probabilities must be 1. So if one of the probabilities gets you 1, this means the other one is 0. That's the whole idea here. Because if both of them are heads, this means the probability of getting heads is 2 over 2. Now let's move on. Here they're explaining that if it's 0, it's impossible. If it's 1, it's certain. If it's in the middle, it's half or even. And the idea of 1 means all possible outcomes or all possible probabilities will be 1 together. So some questions you need to use this information to answer the question, okay? Now, for example, here, they gave you the probability of something happening and the probability of something not happening. And when you add them together, you'll have 1. That's the whole idea, okay? Now let's talk about expected frequency. Expected frequency means what? Basically, once you have the probability of something, you can expect what will happen in the future. Let's take an example. For example, if I have a coin and the coin has heads and tails, okay? Heads on a side, tails on the other side. Now, the probability of heads, let's write it like this, probability of heads equals what? Equals 1 over 2. Equals 1 over 2. And that's the theoretical probability of heads. If I have the theoretical probability, I can work with it. If it's an experiment and I have the relative frequency or the relative probability or the experimental probability, I can use it and work with it. Same idea. Now, the probability of heads is 1 over 2 or half. Now, the question might ask you, if I toss the coin or flip the coin 200 times, how many times do you expect it to land on heads? That's the whole idea of expected frequency or expected probability. So basically, you just take the zero point 0.5, which is 1 over 2, and multiply it by 200 times. And this will give you 100 times. This means that you can find the expected number of times or the expected frequency by using the probability and multiplying it by the number of times or number of trials. That's the whole idea of expected frequency. So basically, expected frequency is number of trials, which is 200 here, multiplied by the probability of the event itself. That's the whole idea. 200 is an example. I'm giving you an example. As I said, if it's tossed 200 times, how many times do you expect it to land on heads? 200 is an example. It's not here in the question. So I made up a question here. If I have heads and tails, and the probability of heads will be 1 over 2. So if I toss it or flip it 200 times, how many times would you expect it to get on heads? That's the whole idea. It's an example, okay? Now let's move on. That's the idea of expected frequency. So let's take a look if we have a question related to expected frequency. Here we have sample space diagram or sample space probability space. Let's see some questions so we can answer here. For example, this one here, we call this a sample space diagram. So you're supposed to fill it and then answer the questions that you have here. The table gives the numbers of boys and girls in a group who wear glasses. This is the table or sample space because it's a probability space. Copy and complete the table first. Let's complete the table. Here we have totals of the ones on the side and totals of the ones on top. So let's complete the table. First, this is 6. When you add it to this, you get 18. So basically that's 12. And 10 plus 12 will be 22. Very good. Now, here, 32 minus 22 will give you, very good, 10. So this one is 10. And 10 minus 6 is 4. Focus how you deal with these tables. The total is here. You have to focus on that. And 4 plus 10 will give you 14. To check, you have to add 14 plus 18. It must give you 32. Now copy and complete the table. We already did it. A person is picked at random. Now focus. When you read questions about probability, focus on what is picked. What is picked at random. If they say a person is picked at random, it means you have to use the total of people. Total of people. If they tell you a girl is picked at random, you have to use the total of girls. If they say a boy is picked at random, you have to use the total of boys. This is very important. Reading the question carefully will help you answer the question. So, a person is picked at random, it means we have to use the total of people. And then what's the probability? The person is a boy without glasses. Now, when you use the total of people, it's going to be in the denominator of the fraction. And the other numbers will be in the numerators. So depending on the question, you have to write your fraction. Now, as we said, 32 will be the denominator for this question. What's the probability? The person is a boy without glasses. A boy without glasses is 10, right? So it's going to be 10 over 32, like this. So here, I'm going to write it 10 over 32. That's the first answer. And then what's the probability of a girl? Girls, as we said, a person is picked at random. How many girls? There are 18. So basically, the probability will be 18 over 32. 18 over 32, like this. As we said, read the question carefully, understand what they need. If a person is picked at random, use the total of people. If a boy is picked at random, use the total of boys. If a girl is picked at random, use the total of girls. Now, question D. Given that a girl is picked at random, here they change the question. They said a girl is picked at random. This means you have to use the total of girls, which is 18. That's why I always say read the questions carefully. Now, what's the probability that she does not wear glasses? No glasses is 12 from the girls, right? And the total that we're going to use is 18. So we're going to say it's going to be 12 over 18. This is very important to answer any probability question. Read the question carefully, understand what they need. Find what's picked at random because what's picked at random must be used in the fraction in the denominator, okay? Now let's move on to the next question. This is how you fill tables and answer questions related to tables or sample space. Okay. Now here, question 7. A coin is fixed so that it has a probability of 1 over 3 of landing on tail. If this coin is tossed 30 times, how many times would you expect it to get hits? Now, basically, the probability of tails is 1 over 3. Focus on this. The probability of tails is 1 over 3. That's what they said. They want how many times will it get or land on heads if you throw 30 times? So basically, first thing you do, you have to find the probability of heads. Find the probability of heads. So let's do this here. As we said, the total number of probabilities is always 1. So we subtract this from 1, 1 minus 1 over 3, like this. It will give me the probability of heads. So first thing I did, I found the probability of heads. Let me do this. So 1 minus 1 over 3 will equal what? Very good. 2 over 3. Now I got the probability of heads because the question is asking about heads. What do I do? Very good. This is the probability of heads. I can write it. Probability of heads like this. Now equals this one. The probability of heads, I'm going to use it to find how many times or find the expected probability. That's the probability of heads. Now I'm going to find the expected probability. So by doing this, multiplying, I'm going to take this and multiply it by the number of times, and I'll find how many times it will land on heads. So I'm going to say 2 over 3. I'll do it like this so you don't get confused. 2 over 3 multiplied by 30. And by that, I'll find the answer for the question. So, yes. So divide by 3 is going to be 1. Divide by 3 is going to be 10. 10 times 2 is going to be 20. So the answer is 20 times. And this is how you find the experimental probability. Now, let's move on to the next question. Okay. Yes. Focus on the steps of sample space diagram and how to fill the gaps. These are very important. Let's see if we can fit it here. Let me do sample space diagram. I think I can fit it in the other video. Okay, let's fit these in the other video, okay? This one and this one, because they're very important. We did the coin thing. Same idea here. Let's do this here so we can finish this video here. It is estimated that the probability of a rainy day in Lagos, Nigeria, is in March is 1 over 4. Work out an estimate for the number of dry days in Lagos from 1 March to 28 March. So the probability of a rainy day is 1 over 4. So the probability of a dry day, we have to subtract it from 1. Good, we have to subtract it from 1. Now, let's cover this here. And multiply it by the number of days that we have, okay? So basically 1st of March till the end of, it's 28 days, right? From 1st of March till 28. Yeah, 28 days. We're talking about 28 days, yes. So basically, as we said, first we find the probability of dry days. So probability of dry equal what? This is the probability of rainy day, which is 1 over 4. So we're going to subtract it from 1. 1 minus 1 over 4, like this. Focus on the questions, read them carefully, because if you don't, you're going to take the 1 over 4 and just multiply it by 28 days. So the answer is 3 over 4. So a dry day is 3 over 4, or the probability of dry days is 3 over 4. Now, I'm going to take the 3 over 4 and multiply it by the number of days, which is 28. So 3 over 4 multiplied by 28, and I'll get the number of dry days in Nigeria. So divide by 4 is going to be 1, divide by 4 is going to be 7. 7 times 3 is going to be 21 days. And this is how you answer a question like this. So focus on the steps. Focus if we need to subtract from 1 or not. If we don't need it, you just have to multiply to get the expected probability. If you need to subtract, subtract first and then multiply to get the expected probability. Thank you very much for watching. See you next time.